Philipp Brunner, Executive Vice President Central Europe at Stadler Rail, will share how intelligent automation and data-driven technologies are transforming tram operations. At the heart of this change is Nova SmartSense, an innovative driver's assistance system that improves safety, punctuality, and energy efficiency, and set the stage for the next generation of automation. Please welcome Philipp Brunner.
Thank you for this introduction. I'm sure you are now in joyful anticipation of what's to come. Dear ladies and gentlemen, I'm honored to be here. I would like to thank to the Polish-Swiss Chamber and the Swiss Embassy for organizing this great event. It's the second time I'm here, and I hope I can contribute something today. We have been asked to rather share something today about the products that we develop, because it is actually a great example of our own Polish-Swiss cooperation in innovation. So all of the things that I'm showing today have actually been developed in a cooperation between our Polish Center of Competence in Engineering and different competence centers in Switzerland, mainly the one in Wallisellen. Just a very quick introduction of Stadler. If you don't know what we do, we make rail vehicles. We're rolling stock manufacturers, mainly in the passenger part, but also locomotives. We have close to 13,000 vehicles running around in 49 different countries, and we work in 16 factories and 80 different locations for service and refurbishment. So it's quite a presence all around the world. You can see here that Poland is quite prominent with 4 locations, taking Center of Competence in Engineering, 3 large factories, plus additionally not visible here are two service and refurbishment locations. The vehicles, as I've said, is rolling stock. It's mainly for passenger operations, but also locomotives. So in Poland, this one is the one you see driving around. More than 100 of those are here, but today we focus rather on the urban transport, so on the metro and on the trams, light rail vehicles as we call them, because this is what the Center of Competence in Poland mostly develops, is software for these vehicles. Now, Stadler does not only develop and manufacture the vehicles, but also a portion of the infrastructure, and especially with a big focus on how to integrate the vehicles into the infrastructure. And this is where a big portion of innovation comes into the place. So while in the individual mobility, in cars, for example, you have the big portion of the intelligence in the vehicle, in the public transport you have the possibility to guide all the vehicles, all the components in the infrastructure, actually by a central intelligence, right? Through so-called communication-based train control or vehicle control. And this is a great advantage we will come into. So as an example, for what products we develop in signaling, first is the Nova SmartSense that you have heard in the introduction. You see a visualization basically of the vehicle through which sensors and systems it can recognize the obstacles and it can assist the driver. This is something very similar actually than most of you today have in your self-driving cars or in your cars with driver assistance systems, just applied to the norms of public transport, being allowed basically to carry hundreds of passengers through a city where they interact with cars, with bikes, and other participants in the road traffic.
Stadler Nova SmartSense is an advanced driver assistance and collision avoidance system for branch line and trams. It contributes to automated and safer driving thanks to high-precision object detection while supporting the driver through further functionalities including sign recognition and high beam assistance. Stadler Nova SmartSense consists of a rail computer and up to 3 different sensors: a radar, a camera and a LiDAR. Powered with artificial intelligence, Stadler Nova SmartSense reliably detects and tracks obstacles, even at night or in difficult weather conditions. Our system supports the train crew in critical situations by recording and classifying potential risks in real time. Various warning levels are then automatically initiated, which can be configured for different visual or acoustic reactions. The driver always maintains control and can override a warning response.
So in the next video, you see then the different levels of automatic driving. And here you've heard now the commentator saying that the driver always remains in control and can override. Of course, this counts until a certain level of automation. For certain operations, the idea is to not having any people involved at all. But for the Nova SmartSense, as you've seen, this is rather something that is known from the automotive sector and is integrated here in public transport, of course. You can see the inputs of the different sensors, and in the video you've seen some examples on how then the software, the algorithm, potentially the artificial intelligence then is making the interpretation for the action actually in operation. So here you can see the obstacle or object identification of the different sensors. As you've heard in the video before, there is a LiDAR, radar, and the smart camera, the same technologies as used in automotive. And this allows then, in combination with all the data that the vehicle gets from the infrastructure. So the big advantage is that it doesn't only have the cameras in the vehicle, but it also has access to the cameras outside, and can also then make run the same algorithms through this data it gets. It also gets a lot of data, for example, from the traffic lights. It gets data from a road crossing, or, for example, it has data about the amount of passengers standing at the platform, already calculating the passenger flow and the time that is required for continuous optimization of the operation, and adjusting the timetable and therefore counting the most efficient energy use in acceleration, deceleration, and so on. This is what we talk about here, or what we see here. Basically, there is a driving recommendations, or then driving recommendations directly executed in the driver assistance systems. And that means that all this data is used to calculate the most optimal acceleration and deceleration. The vehicle has so much data to optimize its acceleration and deceleration, and this is really a great advantage. So in the past, maybe a very experienced driver with all the data available, meaning access to the video feed from the next station, with access to objects blocking the road, he was able to do quite well. But with this is scalable. This is actually applicable to every vehicle in the whole system. We're talking about hundreds of vehicles. And these vehicles can optimize their way and actually increase not only the precision, but also the reliability, and especially the energy consumption. Now, in this video, you see
Stadler
this
Nova,
well
a
explained.
technology that connects people. Flexible, innovative, sustainable. A train control and safety system developed for our customers. Travel with us into a world of modern signaling technology. Our modern, scalable and modular train control and safety system is at the heart of Stadler Nova. It ranges from manual operation to full automation. Metros or streetcars safely regulate their speed. Further, the system can brake and stop automatically. The dispatcher and the driver monitors the system and intervene if necessary. Our Nova system, based on commercial off-the-shelf components, consists of a control center, automatic train protection, automatic train operation, inbuilt interlocking, communication, collision warning system, and diagnostics. All subsystems are combined into a cyber-secured network. Our philosophy is to reduce the trackside components and lifecycle costs. Practically no signals or axle counters are needed. Only the industry-proven RFID tags are used to regulate the traffic and optimize the line capacity. The diagnostics and operational data is collected in redundant data centers at separate locations. Whether for a new or an existing line, Stadler Nova can be migrated and adapted to all requirements and conditions. The system runs with Wi-Fi, 5G, or any desired communication channel. Stadler Nova is in commercial operation, highly reliable and available thanks to a fully redundant system design. That is Stadler Nova.
So for the Swiss people here, you've seen it's Basel Land, our example that we use it in Waldenburg. It's a very good client of ours and a very innovative client, actually allowing us to implement solutions for the first time. In public transport, usually you need the references, right? Where to get it, you need a pilot. And the Basel Land Transport is for us a very great client who is motivated to actually look into such innovative solutions. And now here we have actually a GOA 4, as we call it, operation, so meaning fully automated, completely driverless. So in Waldenburg, we have the driverless shunting to the depot tracks, meaning the vehicles, if they're not driving with passengers, if they're driving empty, they are driving completely automated without any personnel on board, also no supervisor. There is driverless vehicle parking, there is driverless vehicle washing, where the two robots basically play together and wash the vehicle out of the traction of the drive of the vehicle automatic. And there is driverless vehicle arrival at the departure platform. That means it's funny for the passengers as well, because the driver usually just goes to the first tram station and boards the tram that arrives automatically together with the passengers. And then he stays on board for the whole passenger operation, and at the end drops off the tram at the last station, can actually go home, and the tram will take care of maintenance, washing, and parking. Now, with all the data that the vehicle has, and we are talking of many thousand parameters, multiple times per second, that are transmitted. And so there is a massive amount of data from everything. There is temperature, vibration, there is from door opening, from the traction motor, there is all the information from the actual sensors, but also airflow from the air condition. There are many systems that continuously transmit, and the question is what to do with this data. We've had this data for a long, long time, right? The vehicles, they were directly connected via mobile internet for now 10 years or even more. And one of the things that has been developed over the last years is using the digital twin. So it's not only for the operation itself, where you have the full infrastructure mapped out, but also the vehicle itself, using more and more, not everything by far, but more and more of the available data, especially for condition-based maintenance. And we have very interesting applications, for example, for the brake, or for doors, or for air condition, where the vehicle basically analyzes itself virtually with all the data that is available and continuously predicts what is to do and how to prevent it at the right time and to optimize in terms of cost efficiency, in terms of total cost of ownership, every component of the vehicle over the life expectancy of 50 years. This is a huge impact, yeah, to the whole industry, and hopefully also at some point then to passenger ticket prices, right? And the taxpayers' money that is mostly used for these vehicles. So to summarize it, for the future, what is to come, it's completely automatic train operation. I've shown now urban transportation, mainly with the trams, but this is coming in all the public transport sectors. There is definitely increased safety significantly by accessing all the data of the vehicle, but also around and through the infrastructure. Cost reduction and optimization of the operation also in terms of the predictive maintenance, and of course cybersecurity and anomaly monitoring. Now, it was very interesting to see the example of Albertus, of Mr. Schultes, and I'm sure that actually I remember the underwhelming reaction of the businesses, right? And I think that we have very many interfaces or very many applications where a cooperation could be highly interesting. And who knows, maybe Albertus could be a system that actually runs not only, as we've heard, as a co-pilot, but actually runs in terms of a communication-based train control system centrally, a complex system of public transport, including different types of vehicles. More of this, and also what we use, what kind of innovations we drive in the manufacturing itself and in our factories, we can discuss then, hopefully during the panels or also during the networking. Thank you very much.